Everyone, this is the fourth problem that I'm recording for additional review for dynamics for our biomechanics 2021 class. And this problem asks us to look at the position of a boxer's wrist that is measured using a marker-based motion capture system when preparing for a right cross. And it wants us to find the approximate acceleration of the wrist at this point in the punch, or this kind of period of the punch, right? So we have position here at 3 different time points, and we want to find velocity. Of course, we know that velocity is equal to change in position over change in time. We also know that acceleration is equal to change in velocity over change in time. In this case, we do not have a function, we just have data. So the best we're going to be able to do is calculate the average velocity and the average acceleration for discrete points in time. So we're going to use these 3 time series to figure out what those velocities are. So let's start by doing velocity. So for our velocity, I'm going to use the forward difference method. So I'm going to put the velocity at 0.01 seconds. And to get this, I'm going to use the future time. So I'm going to say, let's just write this out a little bit. So I'm going to say position I plus 1 minus position I. Let's write this generically first. Let me get rid of this. So this is just going to be our velocity at some generic position I. So our velocity generic time I. So the position at time I plus 1 minus position at time I over my time at I plus 1 minus my time at I, right? So this is just our delta P over delta T, which is the discrete version of our differential there. So let's look at this for the x and y. So for my x, we have 0.009. Let's do this in a new row. So our velocity at 0.01 seconds is going to be our position at 0.02 seconds minus our position at 0.01 second divided by our time at 0.02 seconds, which is really just 0.02 minus 0.01. If we had a separate index besides just the time values, we could call this like 1, 2, 3, and we could say time at 1, position at 1, etc. Although I don't think that makes that any clearer, so let's just leave it just like that. So for our, let's just do this as a vector. So we have our x value at 2, 0.009, comma 1.208. So that's our x and y at time 0.02 minus our time 0.01, so 0.016, comma 1.206, all of that over 0.01. So our velocity at 0.01, write this as 0.09009 minus 16, or 0.16. That's going to give us negative 0.07. So negative 0.007. And then 1.208 minus 1.206 is going to give us positive 0.002. Of course, all of that is going to be divided by our 0.01. So we're going to move the decimal places forward 2 on each of those. So we're going to say negative 0.7, comma 0.2, and that's going to have units of meters per second. Notice that all these ones here on the top are in meters, and this time difference at the bottom is in seconds. So it gives us meters per second. So that gives us our velocity for the first time period. Now we can look at the same process to get the velocity for the second time period. So I'm going to say velocity at 0.02. And I'm not going to write this out quite as completely, but we'll try and make it a little bit clearer. So I'm just going to do the x component first. So 0.020, that's actually the position in the x at time 3, minus 0.009, that's my x component, and that's the x position at time 0.2. And then we'll do the y's. Our time 3 is 0.0 or 1.207 minus 1.208, right? So there's our y component, and again, all of that is going to be over 0.03 minus 0.02, which, since all these are equally spaced, that denominator is always going to end up being 0.01. All right, so now we can do the actual math here. So 0.020 minus 0.009 is going to give us a positive 0.011. And then 0.7 something something 07 something something 08 is going to give us a negative 0.001. And again, all of that over 0.01. So we're just going to move these decimals forward twice. So we're going to get 1.1 comma 0.1, sorry, negative 0.1, again, meters per second. So what I'm going to do here to make room for me to continue is I'm actually going to add to this table. So I'm going to get my eraser out. I'm just going to make a little bit more room here. Try and get all that stuff. I accidentally erased my bracket on that guy. But I'm going to erase that again in a second here. So I'm going to say I have a new column here. I'm going to call this my x dot and my y dot. And I might have to give myself a little bit more room there, but let's see what it looks like. So my velocity in the x at my time here is going to be 0.7. It's actually negative 0.7. And then at my time 2, it's 1.1. And then in the y, I have at time 1, 0.2. And then at my time 2, I have negative 0.1, right? So I'm just adding kind of onto this table to make a new set of columns for my velocities. And then now to get the acceleration, again, we're going to do the same thing. We're going to do delta v over delta t. It's going to look a lot like what we have here at the bottom. So I'm just going to get rid of all that. Delete. Didn't quite get all of it. And you can always pause and rewind if you want to look at that again. We're going to say our acceleration at time 0.1 is equal to the velocity at 0.02 minus the velocity at 0.01 over the time at 0.02, which is just 0.02 minus 0.01, which is going to have that 0.01 denominator again. So again, we can write this out just like we did the previous one. So we have 1.1, that's the velocity at time 2, minus a negative 0.7. Again, the x values there. And then we have a negative 0.1 and minus a positive 0.2 for our y values. And then all of that's going to be over our 0.01. And again, these top values, these are all in meters per second, right? And this is in seconds. So we see we could get our meters per second squared out of this. So again, our acceleration at 0.1 or 0.01 seconds is going to be equal to, see here, 1.8 0.8 comma negative 0.3, all that over 0.01. So again, we move the decimal place over 2 more. So we're going to get 180 and 30, or negative 30. And this is going to be in meters per second squared. And there's our answer for this problem. So hopefully that makes sense. Fairly straightforward methods for calculating velocity and acceleration given discrete data.